Hi everybody, my name is Srinidhi and my project's name is Mathland. Mathland is a mathematical game that is based on patterns and sequences. In this game, users are given multiple choice questions to answer. Each question comes from various concepts in math. When a user picks a choice, they will be taken to either the next question or they will be taken to a screen that tells them that they are wrong. At the end of the game, users will receive their score. This is the opening scene in my game. In this screen, users will see a start button which when clicked will take them to the first question. As you view the screen with the question, the user must figure out the correct math concept which will help them choose the right answer choice. If, for example, the user selects the wrong answer choice, then they will be taken to this screen. In this screen, they will be notified that they are wrong. After that, they can progress to the next question. Each question is worth 10 points. At the end of the game, the user will receive their score. For this game, I used a lot of UI game objects including buttons, TextMesh Pro, and cubes. The buttons are used for navigating between different scenes and also for selecting the answer choice in each question. The TextMesh Pro was used to display the data in each question. The cubes are also another factor in showing the data, but they were also used as spaces to show the questions. In C#, I used arrays and if loops. The arrays are used to store the question's data, while the if loops were used to determine which scene got loaded next and also for calculating the final score. Some enhancements I would like to do in the future include adding a timer to each question and also adding more questions to the game. I would also like to involve more mathematical concepts. Thank you.
Hello, my name is Chakradwaj Bhattineni and this is my final project. My project is about a ball rolling platform game. It involves a player or the ball traversing through the various platforms and blocks. There are a total of 4 levels. Each level gets progressively harder and contains a new aspect of the game. The second level involves navigating through blocks but with obstacles that move. Hitting the obstacles and making them fall will result in a loss. The third level involves using the obstacles to your advantage. The obstacles must be placed in a manner to mimic a bridge without it falling to the ground to proceed to the next platform. The fourth level involves jumps, where pressing the space button jumps once and pressing it 2 times jumps twice. The momentum from each jump must be controlled to be able to complete the level. Once completing all 4 levels, you can restart and go back to level 1 or end the game. This concludes my final project for this coding class.
Hello, my name is Tanush Mishra and I'm from TM Games, and this is my Unity project game. So this is a very simple game where your goal is to go around this maze and try to collect the gold coins which are around this maze, and there will be a timer which is 25 seconds, and you have to try and get all the coins before the 25-second timer goes to 0. So this is a very simple game because this is my first time using Unity, but I still got how I wanted this game to be. So the controls are WASD for the ball right here. So there will be so if you collect all the 6 coins before the 25-second timer rings, then you win sign will come, which is and then you win the game. But if the 25-second timer goes to 0 and is done, then the ball will disappear and you have to restart the game to try and beat the game again. So now I will show you how does it work now. So as you can see here, there's a 25-second timer on the right hand side of the screen, and the controls are WASD. And you have to try and collect all these rotating coins around the maze. So as you can see, I'm trying to do that right now. So now I cannot collect all the coins before 1 second. So now is 0 seconds is hit, and now the ball has disappeared. So now I have to try restart the game and try and beat it. So now it's loading, and yes. So I can try. Yeah, I can beat it. So now, as you can see here, there's a you win sign right here, and so I completed it before the 25-second timer is there. So now there's a you win sign, and you win the game. So this is my project presentation. Again, I'm Tanush Mishra, and I'm from TM Games, and this is my Unity project presentation. Thank you.
So this is my scene, and this is what I have in my game. Let me move the panel so I can start it. Alright, so to build blocks, you left click. You can also destroy them. You can also move around and jump an infinite amount of times. You can also break blocks using fall damage. Let me show you how this entire thing works. Let's begin with the player controller script. Let me share another screen. Or should I just bring it over here? I use a simple player controller, and I have a simple speed float of 5. I don't know what this is. Well, I do use the WASD keys to move, and I use vector 3 left, vector 3 right, and vector 3 back, and vector 3 forward. Multiply it by my speed flow here, multiply it by time delta time, so that it works for like every frame rate, and not just like a fixed speed. This is my player controller, and I also have a serialized field for this. This is my explosion script, and I have an explosion effect variable here, and I have delay for the delay before the ball, and I have a countdown flow. I have a lot of floats, and it has exploded script. I also have a certain radius that I can apply this to, and a force, which is 10,000. And so I have a countdown float, which is equal to the delay, which is 3 seconds. Countdown is counting down using time delta time, which is basically the basic time function. So it's counting down by 1 seconds in real time. And once countdown reaches 0 and has exploded is not true, it'll instantiate the explosion script, and has exploded is true. And so in the explode script, we can instantiate the explosion effect at the grenade's position and destroy the grenade as well. We're also going to add explosion force in nearby objects in a 200-meter radius. And it's also going to detect if it's a rigid body, and so only exploding the colliders and rigid bodies. Moving on to this one. This is a braking script. I have a high brake force and a pretty low collision multiplier so that it'll explode itself upon impact, or any sort of force above I think around 500. And once the explosion force, reaches above my break force here, 5,000,001, broken is true. The bool broken. And so I will instantiate a replacement, which is a broken version of it. And so each of the pieces of the broken version do have a rigid body, so they will shatter and go apart. And so I've also put a script to get the components of the pieces, making sure that they have rigid bodies. And once they detect it has rigid bodies, I add an explosion force to the pieces. And then I just destroy the original piece, the original unbroken cube. This is the script to instantiate the grenade. It's pretty simple. I press right click which is mouse button 1. And so it instantiates the grenade at the position I want to, which is empty called game object. This I think is a camera rotation script. I have a float X and float Y, which I use to control my mouse. Also have a mouse sensitivity, which I set to -1, and I also have a vector 3 called rotate. I rotate using transform.euler angles, and I also have a rotate vector 3, which is x, y times sensitivity 0. Moving on. I also have a pretty short jump script. I set my jump force to 10, and it also adds force using the rigid body. So if I press space, it adds force using vector 3 dot up. And I multiply it by the jump force, which is 10, which is the y here, and force mode impulse, just third value of the vector 3. That's all it is to the jump script. And this is a script I just got from something from the Unity asset store. I think that's all the scripts. And the explosion effect is also from a package. For the camera, I also used a package called Cinemachine, which I just coded in. And this was made by Daniel, Sandvish, Hardev, and Elijah. I got a lot of models from Blender, but I'm trying to put them in right now, such as like gold blocks from Hardev, a grenade model from Elijah. I think he's still trying to make it into one piece like I'm asked him to. And that's it for now, I guess. I'll share with you guys later.
All right, so this is my project. It is a basic tennis game that people can just play around with and have fun with. It does not have any basic scoring. However, it's just like a testing thing that I made as my project. And then what I did for this, I basically made a court using a plane. And in that plane, I made a bunch of these other planes that are lines. And that's how I made my basic court. And then for the players, I added a basic movement script, as you can see here. And this movement script, it basically uses character controller. And then using that character and controller, it uses WASD and arrow keys to move the character around. And then here in this, I basically just put some boundaries. So the character can't go past like these certain like X coordinates and Z coordinates. And then for the ball, what I did was I added gravity using a rigid body. And I also added bounciness to it so it bounces up and down. So that's how I made my basic components. And then I added colliders to everything so it doesn't like phase through. And I put it as continuous so the object doesn't phase through. And that was one of the main problems I had. Sometimes when the ball hit the player, it would just phase through the player. And then the solution I found for that was just using the continuous collider instead of a discrete collider, so the ball wouldn't phase through the players. And here's a basic demo of my game. So the players move around, as you can see, like the tilt at really weird angles. I add that for a bit of extra challenge for the player to just like play around with it. And then this game, it's really much of a sandbox game. It doesn't actually like involve a lot of gameplay. I just made it to so people can just play around with the sandbox aspect of it. So it's just a basic tennis game. So this is my project, and I hope you liked it.
I made a game called Run Mower. So basically, an alien lands on Earth and he's really hungry. He has to eat these bushes to gain energy. And since it won't be hard for him, it won't be easy for him. I added obstacles. As you see, those are the bushes where he gets his energy from. And the obstacles are those cylinders over there. And the score is slowly getting higher every time I eat these bushes. Oops, I died. And you restart every single time you die. And if you fall off, you also restart. And it always resets your score. See, I fell again. Yeah, and there's like a cheat way. If you like stand here, no obstacle like stands in your way, so you can just go here forever. And it's a forever endless player. Okay, now I'm gonna talk about how the game works, so the scripts. Okay, here's my code. So this is a player movement one. This play shows like where it can move forward automatically. These are the left and right, and this is how it dies when it hits the obstacle. Next is camera follow. So it basically just follows the player forward. It doesn't follow it when it goes left to right. Next is ground tiles. This is where all the ground tiles logic is. It's like where all the logic is. How the infinite plane goes. And yeah, that's how it is. Obstacles is how it kills the player. The coins or food, how it gives the energy. And the game manager is how the score works.
So this is the project created by Unity Merchants. And so this is the game. It's a parkour game in which you have to reach the end of the level as soon as you can. So here, this yellow cube that you see here, this yellow orb, that represents the end of the level. And the red player that you see here, this is a capsule that is used to represent the player. So the way the player was done, as you can see here, it's the overarching player group along with the player capsule and the main camera. So the main camera and player capsule, they're nested inside this larger player thing. So that way, the script for player movement and player collision and whatnot, that's all stored in player, and that will also affect the main camera and the capsule. And so that also allows the main camera to move with the capsule without having to have like any kind of script to make it like follow through with. So here, let's just play the game and once it loads. Alright, so as you can see, we've spawned in here, and this is the tutorial level. So the purpose of these two gates is just to show this is how tall the player is, but you can't jump this high. You can't jump this, but you can walk this. This is here to say that you can't walk this, you can't jump this, but you can crouch this. So you hold left shift to crouch, which makes you shorter, but it'll also make you move slower as a drawback. So here, let's just go to this orange sphere. So to do that, we have to go here, return back, and make the jump that is. And then just go to that pillar, go here, and now we've teleported into the second level. So in this demo, there is only the tutorial level that we just did, and this level, and then that's the end of the tutorial. Or that's the end of the demo, I mean. So, as you can see here, that's the yellow orb. It's a little bit hard to see from the starting position, but this is a good way to find it. So, I'll just go back to the start. So to get up here, you have to go here, go here, go here. And this game was designed with a few shortcuts so that you could save time. Just for example, you can make this jump. Or what you're supposed to do, what the standard thing is you have to, if I can get up there again, I can demonstrate, but the idea is you go there, and then you jump. But you can alternatively just jump straight from here. It's a little time skip. So we have a lot of those throughout the levels since the whole objective of the game is to complete the game as fast as possible. So that's why we made those. So you can jump here and then crouch. So from here, you can either jump on top, which will let you jump up here and then jump up here. That'll let you save time. Or you can, if you miss it, you can just shift crouch and then jump while you crouch, and then that'll let you through here. Although that is slower, so if you time it right, you can get yourself on top of these, and you won't have to crouch, slowing down yourself. But if you do miss that jump that lets you go on top, then you will have to crouch, which makes you lose time. So up here, let's do this. I'm just crouching just so that I get a little bit of time to think. And now we made it up here. And so this is the end of the game. End of demo, as you can see here. So, alright. So now let's go over how this actually works. So the main components of the game is directional lighting, just is for the lighting's purpose. And then here's the player, which I already explained, how it works with the nesting and all that. The environment is all of these cubes and whatnot. The panning tool may make it a little bit harder to access this, but all these blue cubes, this is part of the environment. And here you can see goal, which is this goal. And goal 1 is the goal for the other level that we did. The only reason it's in this scene is in order to prevent a pretty major error that causes like the entire game to break. So that's why it's stored in this scene. Same reason the player is stored in this scene instead of getting like sent to all the other scenes. And for reference, scenes are just different levels in the game. Sample scene here, that just refers to the tutorial level. Level 1, that refers to this level. And then level 2 simply refers this platform here, where we did end up down. Yeah. And so now let's take a look at all the assets here. So down here, this is a plugin. It's called Universal Render Pipeline Global Settings. This is used in order to create volumetric lighting and to just make the rendering pipeline a lot easier. So I use this in order to create a better lighting system. These 3 circles you see down here are textures that we use. The red texture was used on the player. You can't see it since you're in first person, but when you're in scene view, you can see it. The blue texture you see down here, that blue texture is for these obstacles. And then the yellow texture is, and you may notice that the yellow texture down here doesn't really match this. And that's because we have emissions set on, and then it has this color of yellow with intensity added to it. So that intensity will change how it shows. So that's that for visual effects. For the script, there are a few different things. So first there's this scene management script. It's called level finish here, and it's applied onto the 2 goals that we went over earlier. So let it load really quickly. So essentially the way that this works is that if collision tag equals player, which means that if the whatever object this script is applied to, which in this case would be the yellow orbs, which are the goals, if it collides with an object and that object is tagged as player, which if we go back to Unity, we can see that this player has a tag right here. It's tagged as player. So if the thing that it comes into contact to is the player, then scene manager load scene manager get active build index +1. What this does is this will load the next scene. So by default, sample scene, which is the first level, the tutorial level, that's the one that's active or loaded. And so here what it does is it says load the scene that is the current scene +1. And that would just be the next level, of course. So it'll do that. The print here is just for debugging, just because in the console here, it'll show us what the next level will be. Here it says 1. That means it's index of 1, which would be level 1 here. Here, in order to teleport the player, this is what it does. It goes through a bunch of if statements to see what is the next level that it's going to teleport to. And then based on that, it'll teleport the player to a set number of coordinates. But because of the way that Unity works, you first need to disable the player. So for like a split second, the player will be disabled, meaning you can't do anything with the player. It just becomes like a static object. Then it'll teleport you. Then immediately after, it'll re-enable you to do whatever you were doing before. Here, this is just another debugging thing. As you can see here, it'll give you the coordinates that it's sending you to. This is just in the console, just for the developers, but in the actual project, it won't be there for whatever the client is. So that's that for level finish. That's all that really does. Here is do not destroy. This is pretty important because, let me load this up too. Do not destroy is really simple. It's only one line, but it just says whichever objects that these are applied to, and that's applied to the player and these two goals, whatever that's applied to, when you load another scene, don't destroy these objects from the previous scene. Since player, goal, and other goal, they're part of sample scene, that means that when you load level 1, it unloads sample scene, but we don't want it to unload the player or the goals. So that's why we tell it don't unload these. So that's essentially what that does. It's only one line. And the final script is in movement. It's called player movement, and obviously it's applied to the player. Now, instead of being applied to the capsule or the main camera, it's applied to the overall player object, so that way it can also mess with the camera or the capsule. And what this does, it's pretty long, but it's the most important part of the entire game. This is the active walk speed and the active run speed. This will essentially, these are variables that will store the walk speed that you should be at and the run speed that you should be at. So when you run, which is a scrap feature, when you run, it'll say how fast should you be running. That's what active run speed says. And when you walk, how fast you should be walking. Then the next thing, walk speed and run speed, these are just your default walking and running speed. Dash, force, dash upward, those are all for another feature that is unused. Jump power says how high you jump. Gravity is how much gravity affects you. So if I theoretically made that like 40, you'd find yourself jumping kind of high, but you would just go straight back to the ground almost immediately. Look speed X and look speed Y are your sensitivity. For me, I set them to 2 because I thought those were good values for me, but those can be changed for any other player. Look X limit will essentially lock you from like looking too far to the left or to the right. On the X-axis, it'll prevent you from being able to like look around 360 degrees. So it'll limit you so that you can only look 45 degrees on each side. Default height limit is 2F, which is just 2. That's you're 2 units tall. But when you're crouching, you're only 1.5 units tall. Crouch speed is 3, which you will notice up here is a reduction actually because of the way the code works. It's a reduction in speed. But when you crouch, you move slower. And so here we go. Where is it? Move direction just establishes the move direction, establishes the character controller, and some more values to initialize. Can move just says whether you can move or not. This whole thing is just it'll lock your cursor to movement. It'll make it so you can't see your cursor, and it'll set your field of view and say don't destroy on load, and then also establish walk speed and run speed. This is all for movement purposes. It has two different vectors, a forward vector and a right vector. And then these are all used as based on your speed. It'll move you in a certain way, in a certain direction, based on some of these. Now, this is for jumping. If you're jumping, you'll go up the amount of jump power. If you're not, it'll go whichever the movement direction Y is. Now here's another thing. If your character isn't grounded, you will go down. This is just very simple. This is just how gravity works. If you're in midair, it'll just keep moving you down according to delta time, which is just time in Unity. So that's how the gravity works. And then, of course, there's a coefficient here. Key code left shift just says when they click left shift and they're able to move, if they're not grounded, then give them a small speed boost. Otherwise, just no, let it be. Just make them normal crouch. And then, of course, if none of these inputs are there, then it'll just do normally. Character controller move direction times delta times, just moving it really. There's not much to it. This whole thing is for looking around. All of this is for looking around. This is for the y-axis. Here. This is for looking around according to the y-axis. This is where look speed y comes in. And the whole reason this is an if-else statement is that when you're jumping, when you're in midair, the sensitivity at which you look around is decreased. So that's the whole reason this is an if-else statement for is grounded. Otherwise, it would just be just this line instead of this whole thing. And then same thing done down here, except on the other axis. This is just to clamp the look around, which prevents you from looking around 360 degrees. So that's what that does. And yeah, that's the entire game.